एवरीवन, वेलकम टू माय यूट्यूब चैनल फिजिक्स से दोस्ती। और आज हम लोग दोस्ती करेंगे क्लास 10 फिजिक्स के चैप्टर इफेक्ट्स ऑफ करंट के साथ। आई एम योर ओन शिल्पी मैम एंड टुडे इन दिस वीडियो आई विल डिस्कस सीरीज combination of resistors. So let's start. In the series combination, the resistors are joined one after the other. Suppose, children, there are three resistors R1, R2 and R3. Then in series combination, the three resistors are connected end to end, one after the other. Let's see how. Now you can see this place, children. There are three resistors. Resistor R1, resistor R2 and resistor R3. Now they are connected one after the other, end to end, and you can see the three resistors R1, R2 and R3 are connected in series between the points A and D. You can see this place that one end of resistor R1 is connected to the point A and its other end to the resistor R2. Similarly, the other end of resistor R2 is connected to one end of the resistor R3, this place, and the other end of resistor R3 to the point T. Now, this way, the three resistors are connected one after the other. You can see. And between points A and B, we have resistor R1. Between points B and C, we have resistor R2. And between points C and D, we have resistor R3. Now, the ends A and D of the combination are then connected to the terminals of the battery through a key K. You can see this place. This is battery and this is key K. And the three resistors R1, R2 and R3 are connected in series one after the other through the battery. Through the key, it is connected to a battery and current I is flowing through the three resistors. Now, this place you can observe one thing, children, that same current I is flowing through the three resistors R1, R2 and R3. You can see this place, same current I is flowing. So this is very important fact about the series combination of resistors, that is the current has a single path for its flow, hence same current flows through each resistor. You can see this place. Now, one more important fact, you can see this place, same current is flowing through resistor R1, but the potential difference across the resistor R1, R2 and R3 are not same. So, we have different potential difference across the three resistors R1, R2 and R3. Now, across resistor R1, we have potential difference V1. Similarly, across the resistor R2, we have potential difference V2, and across resistor R3, we have potential difference V3. So, this is another important point related to the series combination of resistors. So, let's discuss the two important facts about the series combination. First, the current has a single path for its flow, hence same current passes through each other. This is the first important fact which you should always keep in your mind, that in the series combination of resistors, same current passes through each resistor. Now, second important fact, the potential difference across the entire circuit is equal to the sum of potential difference across the individual resistor. This is the second important point related to the series combination of resistors, which you should always keep in your mind. That is, now let's see how. Suppose there are three resistors connected in series like this. You can see this place, children. This is resistor R1, resistor R2 and resistor R3. They are connected in series. Suppose current I is flowing. Now the same current will flow through the three resistors. Same current I will flow through the three resistors. Now we know the potential difference across the resistors is not same. So across resistor R1 we have potential difference V1. Across resistor R2 we have V2. And potential difference across resistor R3 is V3. So in one more second important fact about the series combination is that the total potential difference across the circuit, that is, if that is represented by V, then that V is equal to V1 plus V2 plus V3. So the potential difference across the entire circuit is equal to the sum of potential difference across the individual resistor. Now these two important points related to series combination you should always keep in your mind. Now we will discuss the expression for equivalent resistance. Suppose, children, if current I is drawn from the battery, the current through each resistor will be same, that is equal to I, that we know. And we also know one more thing, that the potential difference across the entire circuit will be equal to the sum of the potential difference across the individual resistors, that is V1 plus V2 plus V3. Now next we have to find the expression for equivalent resistance. So we know by Ohm's law, we know V is equal to IR, that we know. V represents the potential difference across the circuit, I is the current and R is the resistance. This we know by Ohm's law. Now the potential difference across resistor R1, that is V1, will be equal to IR1 by using this Ohm's law. Similarly, the potential difference across resistor R2 is equal to V2 equal to IR2, and similarly V3 is equal to IR3. Now we know V is equal to V1 plus V2 plus V3. So putting the values, what we will get? This. In place of V, I have written IR, where I represents the current through the circuit and R represents the equivalent resistance. Equivalent resistance of the series combination of resistors, this capital R. And R1, R2 and R3 are the three resistors. Now in this place you can see, since the same current is flowing through the three resistors, so this I will get cancelled, and what we will get, children? We will get R equal to R1 plus R2 plus R3, where capital R represents the equivalent resistance. Thus, we can say that in the series combination or the equivalent resistor, in the series combination, the equivalent resistance is equal to the sum of the individual resistance, that is R, which represents the equivalent resistance, is equal to R1 plus R2 plus R3, that is the sum of the individual resistance. So, if suppose children, we know the value of the three resistors and we have to find the equivalent resistance, what we will do? We will just add the three resistors and we will get the equivalent resistance of the series combination of the circuit. So, that's all for today, children. I hope you are able to understand the series combination of resistors. Thanks for watching. My next video will be related to parallel combination of resistors. Thank you.